Let's discuss the question number 9 from test 3. It's from solid mechanics. Okay, so a steel rod of 4-meter long length is given, and it is fastened between two supports where the left support A is fixed and the right support, between the right support and the end of the steel rod there is a gap of 0.4 mm, and the length of this is 4 meters, length of the steel rod. Okay, so this gap is at 10 degrees centigrade. Now the temperature is raised. The temperature increases to 38 degrees, and now so what is asked is how much is the stress that is introduced in the steel bar. Okay, so basically because of the temperature increase, the delta T is basically 38 minus 10, it is 28. So because of this temperature increase, there will be thermal expansion of the steel bar. Okay, and we are given with two properties. Modulus is given as 210 MPa, and the coefficient of thermal expansion is given as 12 into 10 power minus 6 per degree centigrade. Okay, so now let's find out, suppose assuming that B is not there, then how much it can expand. So that is given by the thermal expansion, I can write as L alpha delta T, assuming that B is not there. So how much it can expand if suppose B is not there due to this temperature increase delta T. So that is alpha value is given 12 into 10 power minus 6, length is given 4 meters, delta T is 28. So if you use a calculator, this comes out to be 1.34 mm. Okay, but now that means if B is not there, this can expand till 1.34 PA, but because of B it will be restricted. So this is what it can expand at 38 degrees. Okay, the total, let's do it like this. So this is your 0.4 mm. Okay, now if it can expand something like this when it is kept at 38 degrees, okay, but you have a gap like this, so it will, the actual expansion will be something like this. So this is your delta L. Okay, and so but it can't expand delta L because there is a fixed support B, so it is basically, this will be compressed by this much amount. Okay, and there will be a compressive force that is developed in the steel rod because of the supports B and A. So now delta L, okay, so because the force has to be developed in the steel rod because of the supports B. So now how much is this? Okay, we can say that this can be visualized as delta L is the expansion due to temperature, but it can expand only 0.4 mm. So the rest of the amount is basically compression by the actual compressive load of P. So that is given as delta P, and that is written as delta L minus the gap. Okay, so delta L is 1.34 minus gap is 0.4 mm. So this comes out to be 0.94 mm. Okay, now this delta P is basically the compression due to the presence of support B. Okay, and this is basically caused by the load P, and so this delta P can be written as PL by AE, just using the Hooke's law, and P by A is your stress, so sigma L by E. Okay, and what I'm asked is how much is the sigma developed, so that will be delta P E by L. So let's plug in the values. Delta P we have already got 0.94 mm, Planck's modulus is 210 into 10 power 6, and length is basically 4 meters. So if you just plug in the values, you will end up getting 49.4 MPa, and it is compression because the load developed is compression. So the answer is B. Thank you.